So, good evening, everyone. This is the A Squared Mechanical Electrical Tutorial Center. Our topic is differential equation. So, first is we need to define what is differential equation. So, differential equation is an equation involving a known function y is equals to the function of x and one or more of its derivative. So the first topic of differential equation is the variable separable, which is an equation of a type that can solve directly by integration. But in order to solve it by integration, all terms containing x must be grouped with dx and y must be grouped with dy. And also that the variable separable has four uh, different differential equation of a type. So later on, we will discuss the equation of a type of variable separable. But first, let's also explain the types of the solution. So the first solution is the general solution, and the second solution is the partial solution. So general solution is a solution that contains arbitrary constant. However, this arbitrary constant is not yet defined, meaning if after integrating, you need to add c in your equation, right? Then the c is called arbitrary constant. So if the value of c is not yet defined, therefore it is called a general solution. Then a solution that uh, no longer contains arbitrary constant is called a partial solution because arbitrary constant is defined. So meaning the c has a value na. So for example, let's tackle on the uh, first differential equation of a type. So the first differential equation of a type of a variable separable is, let's say, some one is, for example, let's say dy over dx is equals to the function of x, where dy will be equal to function of x times dx. So, ningon man tana, all terms containing x must be grouped with dx and y must be grouped with dy since there is no y there and only function of x. So we already group the x dx and the y dy. So now we can start integrating both sides. So the integral of dy is y is equals to the integral of function of x is, let's say, function of x uh, say squared plus c. Or we can say another example is, let's add value. dy over dx is equivalent to x squared. So therefore, dy is equals to x squared times dx. So after grouping the x dx and y dy, we can integral both sides. So the integral of dy is y, and the integral of x squared is x cubed over 3 plus c. So therefore, this equation is called, this solution is called a general solution. So this is the first differential equation of a type of a DE. So this one. So the second differential equation of a type is this. So number two is dy over dx is equivalent to function of y. So number one is dy over dx equals function of x ang number one. Then the number two is dy over dx is equal to function of y. Therefore, dy over function of y uh, function of y function function of y is equals to dx. And after grouping, we can integral both sides. So for example, let's give a value of the function of y. So dy over dx is equivalent to y. Therefore, dy is also equivalent to dy over y is equivalent to dx. Then after integrating both sides, therefore the integral of dy over y is ln y and dx is x plus c. So this solution is also called general solution because the value of c is not yet defined. So let's proceed to number 3. Differential equation of a type number 3. So number 3 is dy over dx is equal to f function of x times uh, g function of y. So this is multiply. So what will happen is you need to group x dx and y dy. So what will happen is dy over g function of y will be equivalent to let's put dx first, then times function of x, and we can integrate both sides. So after integrating, therefore you can get your general solution. But if we get the let's say let's put value function of x and function of y. So dy over dx is equals to let's say x squared times y. What will happen is dy over y is equals to x squared times dx. And integrating both sides because we already done the group of x dx and y dy. So the integral of dy over y is ln y is equals to x cubed over 3 plus c. Therefore, the solution of number 3 is also the general solution because it has the c has no value, or it is not yet defined. Then let's go to the last or number 4 differential equation of a type of the variable separable. So number 4 differential equation of a type is dq over dt is equivalent to uh, q, where the general equation is q c e raised to the power of t. Then therefore, in order to understand this equation, we need to get a example. So for example, dy over dx is equals to 3y. So this sample can be solved using differential equation of a type number 2. But let's just try to solve first using number 4 differential equation of a type. So q is equivalent to y and t is equivalent to x, and k is equivalent to 3 because that is the k and it is the y from here, right? So therefore, we need to substitute this value to here. So what will happen is q will become y, c is copy, e is copy, and k will be 3, and t will become x. So this will be the general solution. of the example. But let's try to solve using number 2 differential equation of a type. So let's try to solve. Uh, dy over dx is equivalent to 3y. So therefore, let's group the terms containing x and dx. So dy over y is equals to 3 dx. Then let's integrate both sides. So the integral of dy over y is ln y equals integral of 3 is 3x plus ln c. Then ln y, I'm gonna go, let's transpose ln c to ln y. So ln c equals 3. And the law of logarithm is ln can be written also by y over c is equals to 3. Now let's add e to the ln y over c. I mean 3x. 3x is equals to e to the 3x. So e to the ln is 1. So what will happen is y over c is equivalent to e 3x, and c multiplied to e is y is equals to c e raised to power of 3x. So equal gihapon ang mahitabo. So that is the final answer. So that is your general solution. So mao gyapon, the same gyapon answer si number 2 ug si number 4. So any differential obligation at type, basta you understand the concept, you can solve anything sa variables parable.